Hi class, I wanted to do a video showing you how to calculate a 3x3 determinant by hand. There's a couple of methods that you can employ here. The first one is the one that most math majors typically use, and that's called expanding by minors. So I'll show that one first. To expand by minors, the basic idea is you need to pick a row or a column about which you plan to expand. So for example, let's suppose that you decide to choose the first column here of this 3x3 matrix. So you make your choice. So I chose the first column. You could choose any column or any row. And then what you want to remember is for a 3x3 matrix, the signs will either change or stay the same for each new factor. So what we notice here, for example, is in the 3x3, the sign change chart would be plus, minus, plus for the first row, minus, plus, minus for the second row, plus, minus, plus for the third row. Okay, what that means, remember, plus just means keep the signs the way they are, minus means change the signs. So if it was a negative already, it would become positive, etc. So if I chose the first column here, then what this means is the very first thing I would do is write the determinant. Usually we write the absolute value bars here, or you could write det of a. That's another option, so I'll just show you what I mean. You'll see both of these notations. Either way, they both mean determinant of the matrix. The very first thing you would want to do then is take the 2 and say I'll be multiplying 2 by its minor determinant. And then take the opposite, so we're doing the first column, we're doing a keep, change, and a keep. If I had done the second column, I would have done change, keep, change, etc. So I'll keep 2 the way it is and multiply by its minor. Then I'm going to take the opposite of the next entry, 5. It's already positive, so now it'll become negative. And that factor will be found by multiplying it by its minor determinant. And then here's the tricky one. The last one, you're going to keep the sign the way it is, but the sign is a negative. So I'll just write it as keep it a -1. You could also just write -1 if you want to go faster, but I wanted you to see what's happening in reality. So let's take a look at now what these minor determinants actually look like. So how do you find these minor determinants? Well, for 2's minor determinant, you're looking, instead of a 3x3, because that's the big size of the whole matrix, you're looking for a minor which is 1 less in each side, 2x2. So the minor would be every entry that's not in the same row nor column. That leaves us with 6, 5, -2, 5. So let's write that. 6, 5, -2, 5. For the minor of 5, you take every entry of the original 3x3 matrix, which is not in the same row or column, which is -3, 4, -2, 5. Watch my signs if I make a mistake. It happens. -3, 4, -2, 5. And for the minor for -1, you take every entry that's not in its row or its column, which is -3, 4, 6, 5. -3, 4, 6, 5. Okay, so where are we now? Well, at this point, we need to take our 2x2 determinants, which should be pretty easy to do if you remember that diagonal pattern, right, of products and subtracting the difference. So how do we find those? We went down. 6 times 5 here is 30. And then we subtract going the other direction. So you keep going one way and you change going the other way. Sorry if you can't see that anymore. -2 times 5 is -10. So we're going to be taking the opposite of that. Now that entire result gets multiplied by the number in front, which was a 2. Let's head over to our next minor here. We'd have -3 times 5, which is -15. And then we'd have -2 times 4, which is -8. But you take the opposite. Again, you keep, and then you change. So the -15 was the result when you went down. You kept it the way it was. -8 is the result when you go up. So taking the opposite of that, that's +8. So I'll just save a step instead of putting a double negative, if that's okay. And in front, we had the -5 getting multiplied. Finally, we'll have our -1 times the result of this 2x2 determinant, which looks like -15 minus 24. So what is negative 15 minus 24? That's negative 39. Okay, so now at this point, let's go ahead and do the arithmetic here. We'd have 2 times 30, watch your double negative, 30 plus 10 is 40, minus 5 times, here we have negative 15 plus 8, so I'm getting negative 7. And here we have a negative 1 times a negative 39, that's positive 39. So multiplying here, that's 80, 2 times 40. Multiplying here, watch your signs, that's positive 35 because a negative times a negative, and positive 39. So 80 plus 35, that's 115, plus 39, I'm looking at 154. Now, technically you could use technology to check any determinant as long as you have numbers given to you, but sometimes as you get into higher level math or on final exam sometimes, just to make sure I know that you know what you're doing, I'll put letters in here, and so you might end up with like A plus B, and you just have to leave those letters the way they are if they're not like terms. So just be aware of that. Determinants are very nice if you have numbers because you can check them with your technology, but if the entries are letters, you'd have to actually show those letters throughout the problem. Okay, let me show you the alternative way of doing this problem that some students, actually many students, prefer. The second approach to solve this problem will be to do what we say is the engineer's method. So this is more of the mathematician major or math major way of doing things because it can easily be expanded out, generalized I should say, for an n by n situation. But if you want to have a nice clean and dirty way of doing this for 3 by 3 matrices, you can do the diagonals approach or the engineer's method. And the first thing you would want to do is you would want to copy and paste those first 2 columns to the right of the determinant. So for example here, you would take your original 2, I should have actually been more clear, A was actually a matrix, like that, okay. And then it became that, okay. So the determinant version was 2, negative 3, 4, 5, 6, 5, negative 1, negative 2, and 5, if I copy that correctly. So to find its determinant, that's the absolute value looking bars mean. So without the absolute value bars, the brackets are just the original matrix. I should have copied that better, sorry. Okay, so to find the determinant of that 3 by 3 matrix, the first things first is you would copy and paste your original first 2 columns. So I'm going to put this 2, 5, negative 1 column right here. And then I'm going to put this negative 3, 6, negative 2 column here. Okay, so what do we do next? Well, the idea with the diagonals approach is you're trying to mimic what you do for a 2 by 2 determinant, which was down, multiplying down the diagonal, you keep signs the way they are, left to right. Multiplying up from left to right, you take the opposite of those products. Okay, so similarly now the reason we've done that is because if you had just gone down and then just gone up, you would have missed several numbers, right? And so by putting these 2 extra columns, you actually end up talking about all the entries. So it's a very clever way of doing things. So let's see what happens if I take the first diagonal down. It's 2 times 6 times 5. So writing this out, I keep those the way they are because we're going down left to right. So 2 times 6 times 5. And then I'm going to keep the next diagonal the way it is as well. So I keep that plus sign in front to indicate that. Negative 3 times 5 is negative 15. Negative 15 times negative 1 is positive 15. So I'm going to keep that 15 the way it is. Feel free to write out the steps if you need to. And again, that was going down left to right, so I keep the sign the way it is. And one more diagonal to go down is 4 times 5, which is 20, and 20 times negative 2 is negative 40. But I'm going to keep that the way it is, negative 40. But now as I go the other direction, diagonals coming up from left to right will be taking the opposites of those results. So let's do that carefully. Here's negative 1 times 6 times 4. No, this is when I take the opposite. Okay, so take the opposite. I'll just loop around here if you don't mind. Take the opposite of this result. Negative 1 times 6 is negative 6. Negative 6 times 4 is negative 24. So we're taking the opposite of negative 24, so you know that's positive 24 if you want to skip a step. Then take the opposite of this diagonal, going up from left to right. Negative 2 times 5 is negative 10. Negative 10 times 2 is negative 20. So I'll be taking the opposite of negative 20, or you could just write plus 20 here. And the final diagonal going up from left to right, so taking the opposite, is 5 times 5, which is 25. 25 times negative 3 is negative 75. So I take the opposite of this result since I went up from left to right. So it was negative 75. Taking the opposite, you're free to write plus 75 if you want to save time. Okay, so let's see where that leads us to. Combining all 6 of these numbers, the first product here is 30 times 2, which is 60. It was positive, plus the 15. A plus and a negative there, that's a minus 40. And then let's continue with the numbers that were below. We had a positive 24. We had a positive 20. And a positive 75 when we took all those opposites. And again, sometimes it's the opposite of a negative, sometimes it's an opposite of a positive. You just have to remember what opposite means. Let's combine those like terms. They're all like terms. So 60 plus 15 is 75. 75 minus 40. So there you get your 35. 35 plus 24. So you're getting your 80. Did I say that right? 35 plus 24, 59. Then you get your 20 added to that, 79. And 79 plus 75, you're looking at 154. So you should be getting the same result regardless of which way you did the problem, okay? So again, keep in mind, you can definitely use technology to check these 3x3 determinants, whether it's a TI calculator or some other internet-based one, since you're able to do that when you're on your own. However, keep in mind, when these turn into letters, you have to be able to demonstrate your work. So if this was an A, for example, everywhere you see this 2, you'd have an A instead to distribute. So be sure you're comfortable finding 3x3 matrices, not just with numbers, but with letters or other random symbols, just to make sure you understand the process, okay? If you have any questions, please reach out to me. Otherwise, happy practicing, because math is not a spectator sport. I'll see you next time.